projects. In this video, we are going to see understanding urban dynamics from massive mobile traffic data. Introduction. Data from mobile traffic has increased significantly over the last 10 years. Analyzing traffic patterns requires a thorough understanding of ecological concepts and human behavior in urban settings. ISPs, that are internet service providers, require this information to locate towers and implement measures to reduce traffic loads during peak times. Thousands of towers worth of mobile traffic data have been analyzed and modeled using a system that divides traffic consumption into trend, seasonal, and residual components using the time series analysis theory. The system forecasts mobile data traffic, models human activity patterns, and analyzes traffic logs to identify unusual events. Objective of the project. This project makes use of a theory to comprehend and foretell urban traffic patterns and the consumption of mobile internet traffic data. The installation of mobile towers can ease congestion, and internet service providers can do this by analyzing this data. By dividing the data into 10-minute time series, the project avoids situations in which unexpected abnormal events happen suddenly. The project can identify typical locations with heavy traffic if it sees consistent traffic on different days. Internet service providers can add new towers and take down those with low traffic by analyzing this traffic. A mobile traffic dataset from Shanghai Mobile Towers is used in the project implementation. Requirements. These are the requirements to execute this project. Hardware requirements. Operating system of Windows, processor of i5 and above, RAM of 4GB and above, hard disk of 20GB and above. Software requirements needed are Python IDL of Python 3.7 version. To execute this project, we have designed the following modules. The first module is Upload Mobile Traffic Dataset. Using this module, we will upload the mobile traffic dataset to application. The second module is Decompose Data into 10 minutes time series. Decomposition splits data into smaller parts for analysis. This algorithm splits the mobile traffic dataset into smaller time intervals, 10-minute series, to facilitate analysis and pattern recognition. In this project, it helps to identify normal traffic patterns by removing data spikes caused by traffic jams or accidents. The next module is Agglomerative Hierarchical Clustering to identify key traffic patterns. Agglomerative clustering groups similar data points together to form clusters based on their similarity. This algorithm groups similar mobile traffic patterns into clusters based on data consumption rates. In the project, it is employed to identify days and times when huge mobile traffic consumption occurs, allowing internet service providers to make informed decisions on tower deployment. The next module is Weekdays Traffic Pattern. Using this, we will scan entire dataset to plot pie chart with traffic patterns on different days of week. From this, we will understand which day traffic is more or less. The last module is ARIMA Traffic Forecasting. ARIMA, Auto-Regressive Integrated Moving Average, is a time series forecasting method that predicts future values based on past patterns. In this project, it uses labeled traffic data from clustering to predict future traffic consumption accurately. It predicts patterns for weekdays, weekends, residential areas, and office areas to forecast traffic for the next 7 days, aiding in capacity planning and optimization of network's resources. Execution of the project. To execute this project, first we have to open the code folder. This is the code folder. This is the dataset folder in which I have required dataset. These are the Python main code files. This is the run.bat file. Instead of executing the project in command line interface, we have created this run.bat file. Double click on run.bat file. A graphical user interface will be opened. With this, we are interacting with the program. We have used Tkinter library to create this graphical user interface. Now click on Upload Mobile Traffic Dataset button. A dialog box opens. Select the dataset and click on Select Folder. It confirms that the dataset is loaded. Now click on Decompose Data into 10 minutes time series button. We can see the records which are divided into 10 minutes time series where we have date, base station ID and internet traffic consumption in that 10 minutes. Now click on Agglomerative hierarchical clustering to identify key traffic patterns. We can see different traffic consumption rate goes to different clusters. We can see in cluster 3 there is traffic consumption of 5902 petabytes. So using clustering we segregate different consumption rate into different clusters. Now scroll down screen to see consumption rate of each cluster. Here we can see POI, that is point of interest cluster distribution. There is 264% of consumption increase in second cluster and less traffic occurs on weekend days. Now click on weekdays traffic pattern button. In this graph we can see day count from 0 to 6 and 5th and 3rd days of week we can see huge traffic rate, and in last day of week we can see less consumption as people are relaxing on weekends. Now we got dataset and some traffic patterns, and we can use these patterns to train ARIMA forecast algorithm. And after training ARIMA, we will forecast traffic for next 7 days. Now click on ARIMA traffic forecasting button. We got forecast traffic for ARIMA for next 7 days. Click on exit to exit from this window. The conclusion here is this project effectively makes use of mobile traffic data to comprehend and predict urban internet traffic patterns and consumption. Agglomerative hierarchical clustering is used in the project to identify important traffic patterns and groups with comparable data consumption rates, enabling internet service providers to place mobile towers in the best locations and reduce congestion. The project achieves precise traffic forecast for the following 7 days by using the ARIMA traffic forecast algorithm. The project offers insightful information for enhancing service delivery in urban settings and optimizing mobile network infrastructure.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.